So I will be talking about the materials and methods and results for the potato part of the project. So the potato part of the project involved two procedures with two separate results. One was to specifically quantify just the percent starch that was in the potato flour we had, and the other was within that starch to determine what the ratio of amylose to amylopectin was. So to purely determine how much starch there was in the potato flour, we originally had planned to use a procedure from one of the literature sources that involved using glucosidase to degrade the starch into glucose, and then using spectrophotometry and equation that they had derived to measure the amount of starch. However, we were unable to get the glucosidase that was required for that procedure, and all we had was amylase, which would degrade the starch to maltose. So instead, we used the amylase to degrade the starch to maltose, the 40 milligrams of flour that we had to start with, and we used a Benedict's reagent, so a colored chemical that turns colorless upon binding to the reducing end of a sugar, to quantify the exact amount of starch present by there's a chart in the results section, which I'll get to in a minute, which shows the exact ratios of mass of maltose that will react with the Benedict's. And then as far as the amylose to amylopectin ratio, we took more of the raw flour, and after washing it out, we used an iodine dye solution, so it was 0.2% iodine and 2% potassium iodide. That produces a characteristic purple color upon binding to the amylose. And then we did spectral analysis at 620 nanometers with a standard curve of 0.02185 times concentration equaling absorbance that was derived from the literature, using standards ranging from 10 to 100% amylose. And the percent amylopectin, on the other hand, was determined by subtracting that percent amylose we found from 100. So going over to our results then, we ended up using 8.5 milliliters of the Benedict's solution to fully account for all the maltose present. And based on the ratio in the chart down there, we just multiplied the 8.5 times that amount in grams of maltose that it would reduce, and then convert it to milligrams to determine that we had a total of 23.97 milligrams of starch-derived maltose present. And then dividing that by the 40 milligrams we started with gave us a percent starch of 59.93. This fell within the range that we saw in the literature. However, it was a little low, but not alarmingly so. We discuss a couple reasons why it might have been low in the discussion a little later in this presentation. The absorbance of the iodine amylose complex was 0.166, which, working with the standard curve, gave us a concentration after dilution of 7.58 milligrams per liter. Before dilution, the mass was 3.45 milligrams. This gave us a percent amylose of 14.3, which falls comfortably into the range that was outlined in the literature. And again, we discussed some of the reasoning for why we got this result further on in the discussion.